Hello, everyone. I hope everyone is doing well. Today, we're going to have a brief discussion regarding how to convert your house to a sustainable residence with a minimal cost. During today's presentations, we are going to discuss two elements. Element number one is a PV solar system for residential property. Element number two is biogas. This lecture it's aimed for the MENA region, Middle East and African countries, where they have substantial amount of sunlight, substantial amount of hours of sunlight, where they have also sufficient water resources to support their plantation and their house need. So this presentations basically it's going to capture the solar energy, how to convert the solar energy into electricity using PV technologies, and how can we obtain the gas using the biogas system. We are not going into detailed analysis. We just going to show that with minimal cost, it is possible for us to grasp the requirements to be a fully sustainable house. What's a house electric requirements? We need to understand what's inside a standard house. Inside a standard house, we have a television, we have a lightings, we have a water pumps, we have washing machine, kitchen appliances, we have another miscellaneous, which could be phone charger, laptop, electric tool, etc. When it comes to the standard house, and when it comes to the cooking appliances, we have two main elements. We have the cooktop, we have the oven. Now, what we want to show that it is possible with a small energy management system. It is possible for us to have a small system to support the house activities. When it comes to the PV solar system, the component of the PV solar system, what are they? They are solar panels, you have electrical protections, inverter. I want to consider that I don't have a grid for to be the worst case. I will have an energy storage with electrical protection, and then I have my house load, and of course the steel structure that I will install the solar panels on top. Currently, currently as we speak, the news everywhere that the cost per watt dropped to less than $0.22 or 22 cents per watt. A reputable 5 kilowatt inverter, acceptable brand, the price is around $900. Energy storage, for the energy storage, we have the lithium iron phosphate. It's a very popular type and it's very suitable for house battery system storage system. And the cost per kilowatt hour is between $250 to $300 from acceptable quality. And you have the steel structure for the standard house, PV for the standard house, it's around $50 per panel. So if I look at the 5 kilowatt system, if I look at the 5 kilowatt system, which is give you up to 20 ampere single phase, it's suitable to run a standard house. I'm not talking about a mansion, I'm talking about a standard house. And again, I am not considering very heavy electric equipment that will be deployed at the house. I'm talking about standard house. So the cost will be around $4,550 for the system to be installed and commissioned. Now, when I look at the biogas system, the technology allows us to have the biogas to support multiple appliances: stove, lamp, rice cooker, freezers, generators, water heater. In our system, we want to use it purely for cooking and hot water, or some part of it heating as well. Okay, now our system that we want to use, we want our biogas to produce what's equivalent to 1.5 to 2 liter of LPG, or equivalent to LPG. This is sufficient to run the one stove for at least 3 hours. With experience, you can run it for 2 liter, you will run it way more than 3 hours. Even 1.5 liter will run it way more than 3 hours. And if you have the right environment and you have the right mixture of a green waste, it will give you within the 24 hours. If you give more feed and you have the right environment, right setup, it will give you around 5 hours per day, the same setup for the biogas. So the cost of the entire system installed is around $700. Could be less, could be more. If you go ahead and you search online, maybe you find way cheaper product. However, I'm talking about an acceptable product to be deployed. To be deployed. Okay, and this feed is based on a cow dung and a green waste. Every single green waste from the house can be used. Also, if you have a garden outside, you can use the garden as well, or the green waste from the garden can be put. If you have any animal waste, you can put. If you have a cow dung, will be perfect as well for it. So when it comes to my system that I will deploy, first I need to understand the house electric operation. If I have a new LED TV, it's less than 100 watt. The LED light, it's around 11 watt each. I have the washing machine is around 1800 watt, some maybe a little bit more, a little bit less. Other appliances, it's about 600 watt if I have a multiple laptop, for example, iPad, and so on. If I have a water pump, the water pump could vary for a house. Could be 1 horsepower, 2 horsepower, 2.5, 3 horsepower. But usually on an average, based on our experience, it's about 1200 watt, between 0.7 to around the 1200, maximum 1500 watt they utilize. Now, the refrigerator usually, if you have a decent one, it's a less than 1 kilowatt hour, or around 1 kilowatt hour per 24 hours. Okay, now how do I have the sequence of operations in this housing? Because I'm aiming for a sustainable house, I need to adjust, I need to adapt to the weather condition, I need to adapt to the surrounding environment and infrastructure. So when I have it during the daytime, I have two conditions. I have a sunny day where I can run all my appliances, but I run it one after one. For example, I run the washing machine for 2 hours with the miscellaneous. That will give me 2400 watt, 2000, 2.4 kilowatt. And then I can, after I finish, I can run the water pump, okay, with other appliances. I always avoid running two heavy machines, like a washing machine. If I have a dishwasher, maybe, I try to avoid to run the washing machine along with the water pump. Okay, so for me, I need to be able to manage, and this can be managed very easily. I can have a small device with a timer that will run during sunny day. It will run the washing machine, for example, between 10 and 12, and run your water pump from 12 to 2 to 3, depending how many hours you need. During rainy day or a cloudy day, we need to limit the consumption to the critical. What are the critical? I need to watch TV if I'm at home. I need to turn lights if the sun is not sufficient, and I need to have the refrigerator. Now, of course, part of it as well, it's a miscellaneous. Part of it, it's a laptop. If you have a laptop, but laptop, it's a very, very, very small. in comparison to a washing machine or to water pump. And at night also I need to limit. So if you look at the standard house, I will have around 15, maybe 20 kilowatt hour per day if I'm running all appliances. If I limit, I will have 1.2 kilowatt hour, maybe 1.5 kilowatt hour, maybe one. If I limit only, I run the critical appliances. And this is a very conservative approach. And during the sunny days, to look at it more into a little bit details, during sunny days, the 5 kilowatt system will give me between 20 to 30 kilowatt hour per day. Is it winter season? Maybe it'll give me around 20. Summer will give me around 30 kilowatt hour. That's why in summer, it is acceptable, maybe during the day, to deploy a small air condition inverter that you can also use. Now, because during the nighttime, we are going to limit our energy storage deployment to the minimal possible, which mean we're gonna have the battery, it's going to be less than 2 kilowatt hour. So in another word, during the daytime, during the sunny period, I can have between 18 to 28 kilowatt hour for the house deployment. With current technology, current home automation, it doesn't cost a lot of money, couple of $100, you can deploy or apply a sophisticated PV system or automation system with the PV system to consume all this energy. You can direct it to heating, you can direct it to water, you can direct it to create ice, you can direct it to create cooling environment. It's a very easy to achieve these requirements. Now, during a cloudy and rainy days, everyone should know during a cloudy days, the system still give a percentage depending the level of the cloud. If you have a heavy black cloud with rainy conditions, of course, you're going to have no output considered. But usually in the Mediterranean or in the Middle East or the African, you will have during the day, sometimes you have days, partially cloudy days, or light cloud days. You don't have the sun, you cannot see the sun, but you still can see an output of your system. If your system still maintains 10% of the system output for 6 hours, that's a 3 kilowatt hour, which equate to more than what you need to run your critical load for 24 hours. So even if it's a light cloud or partially cloud or 50% cloud, you still can achieve the output of your PV system. Remember, your cooking and your heating, will be on the biogas. And again, when I say per day about 2 liters of biogas equivalent to LPG, that means every person, when they have the LPG gas heater, they every 20 days, every month, they need about 11 liter or 12 kilogram system or 11 kilogram system per month. No one in reality run the heater 24/7. Okay, and remember, we're not in an environment where it's heavily cold during 10 months a year. The weather it's acceptable for 10 months a year. Now during the 2 months that heavily rain, we need to adapt with a backup generator. However, based on our experience in the Middle East, it is possible to adjust as long you remove the heating element into different source. You can adjust and it can be fully sustainable when it comes to PV system and biogas for at least 10 months a year. To conclude, for a system less than $5,500 for a standard house, the resident will have an access. They can run their full appliances during the day when there's sufficient sun, critical appliances during sunny and rainy days. The house will have a minimum of 3 hours cooking per day. This cooking per day, they can increase their plantation element for the garden, and they can start preparing all their, you know, advance their cooking. They can prepare food for winter. They can, they can advance their sustainability when it comes to food security. There will be no electricity bills, no gas bills. The waste output of the biogas are suitable to be reused for plantation. Actually, it's a very good fertilizer. And finally, it will reduce the waste of the household. Majority of the waste, if it's an animal waste, if it's a food waste, if it's a green waste, all of it will go into the digester. So basically, the house will only have waste if they use plastic and similar type to plastic waste. I hope that's a clear, and I'm planning to go into more detail in future videos about every single aspect of the design, implementation, operation, maintenance of this system. However, I say it one more time, based on our experience in the region, it is possible to combine the biogas along with the solar system to have a fully sustainable house with zero electricity bill, zero gas bill. Thank you for listening and wish you all the best. And we'll see you uh, during our next video. Thank you.